As an addition to my initial trilogy of videos on melting connectors, something's coming into view. So initially I did these are for turbo connectors. Let's see how much current they could take before they melt. See that one? This time it's the turn of Tamiya connectors. Very common, very popular on battery packs for boats and what have you. So this is what they look like when they're new and unbutchered, not like the next one I'm going to show you. These are supposed to be good for about 15 amps apparently, so we're going to see if we can find out. I have a little setup here which I have kindly butchered. I've just removed some of the plastic on there so you can see the pins and see if they can get hot. I've only ever had one complaint about these from an anonymous customer, who shall remain anonymous, but Mr. Bellamy said they were only good for about 1 amp. Yeah, Mr. Bellamy, okay. So we're going to put that to the test. So my setup, same as I've done in previous videos. You might want to watch that one, makes any sense to you. I've got a load tester, microscope, and a big 12-volt bike battery. So there's not much involved here. It's battery, connector, and load tester. What I'm going to do before I go any further, I'm going to melt. I'm going to soften some of this plastic with the soldering iron. Hold on. So my feel is that this is probably a polypropylene. It's got a waxy feel to it, or maybe low density polyethylene maybe. Let's find out if I've got any nasal memory. Let's melt some of this. Doesn't smell much of anything. It's probably polypropylene. If there's something horrible, I could. Probably polypropylene. That's all I've got for you on that one. So I don't think any further messing about. Let's stick that under the microscope and apply some current to it. I put a piece of plastic on there and coloured it blue, so you can see if you can see it melting. It's the same plastic. It's come off the same connector. Let's go. Sparks. Start gently. 15 amp. Let's see what my battery's good for. The piece of plastic I've put there, it's on top of the pins where the 2 pins meet. It's making a noise. It's making a noise here. Yeah, where the 2 pins meet, where the resistance will be at the greatest. It's coming up to 9 minutes and it's obviously not going to be enough. It's not enough current, so I'll have to change tack I think and use a lower voltage battery, use a 4.8 volt, see if we can get more current out of it. So the same thing again, but with a different battery, 4.8 volt battery, a lower voltage, more amps, hopefully. I'm not going to mess about with 15, 20. See if it'll take 20. I did on 20 on the other one, didn't I? 25. maxed that out. 23.6 amps. That's all it'll give me. What if I turn this knob, will that give me some more? 25 amps. Something's fizzing. What's fizzing? I wonder if it's the battery that's fizzing. I don't know, before the connector. I'm going to run that until it melts. If it melts. If it doesn't, I'm going to need something that'll give me more amperage, which I haven't got yet. Oh, current's dropping on that, so the battery's had enough. Okay, fair enough. Turn the load off. That's had enough. So the battery lasted for about 8 minutes. And non-melted. 100 degrees. Not quite enough. 25 amps. Not good enough. I probably need about 30. Maybe even more. It's not something I've got. So, another rethink. And so it's time to step it up a notch. I need more amps. So instead of having one 4.8 volt battery, I've acquired another one. Now I have two. I'm going to stick these two in parallel. Just giving off my connector lead there. A couple of Deans. So one battery gave me 27 amps. I'm hoping that two batteries will give me double that, up to 54 amps maybe. I've put thicker wires on these as well. I'm not testing the wire, I'm testing the connector. On the output side, I put in a MCB breaker. It's rated at 40 amps. I was hoping to use a 63 amp one. I know I've got one somewhere, but can I find it? No. I'm also putting a switch in there just in case things go tits up. So if things go really badly, I can quickly disconnect it. And as for the load side, I'm not going to be using this electronic load. I'll call it by its correct name this time. Not a what did I call it last time? A DC load or something. I'm not going to be using that. I need to go old school. So for a load, this is going to stay in one piece while I try and maneuver it into shot. This is nichrome wire. It's 16 gauge, it's about 1 mil thick, something like that. It's about 1 meter long. But more importantly, it's half an ohm resistance per meter. This is the bucket of special cooling solution, otherwise known as tap water. Put a couple of tiles in the bottom there just in case the nichrome wire gets hot enough to melt the bottom of the bucket. So that's a nichrome wire sitting in the cooling solution. I've set that on about, what did I say, about 400 mil, 18 inches. Hopefully that'll give me about, what did I say, 0.2 ohms. By my calculations, that should be about 20 amps. Let's try it. Strip it. Yeah, 20 amps. Tell me my calculations were right. 20 amps. But it's not enough. Not enough. I have to change the tapping point of that and try and get 30. Okay, so I've moved that now to 200 mil, 8 inches. Hopefully it'll be about 0.1 ohms. But I thought that would give me about 40 amps. But let's see what happens. You can hear that. 34 amps. Okay, let's give it 34 amps and see if my connector melts. Or the batteries melt first. 35 amps not enough. Okay. Maximum about 80, 81. Well, let's have a reset and go for less resistance, more amps. And so on to part 16 of this sorry saga. It's not part 16, just feels that way. Same setup as before. 2 new freshly charged batteries there again. The only difference is I've done away with the circuit breaker, because that was 40 amps and it would probably trip. And I've changed the wire, the element side a little bit. I put a couple of tapping off points on there, so it's going to be between positive that side and negative on one of these. So with no switch on this, I'm going to be relying on opening the circuit by just taking the crocodile clip off. Hopefully it's not going to get too hot, and hopefully we can get about 45 amps. So my elements in the bucket. We said that water and electricity don't mix. So getting underwater sparks. Oh, we do. Overload. Oh, so it's 60 amps. Try again. Oh, 60 amp. Too much. Change tapping off points. Let's try again and move the tap off point a bit further away. The furthest one gives me 46, that's fine. Go! Let's see how long it'll maintain that 45 amps. It's not going to last very long, probably about 10 minutes maximum. And that's 10 minutes. Still no melty. Still at 117. Strange that the furthest one is hotter. 26. So that's 12 minutes in. That's going to be it for this test. I think the current is dropping fairly rapidly. I'm not melting anything. Reset again. Charge them up again. Next time I'm going straight for 60 amps. Piss about. So, take 17. I've charged the batteries up again. I made a couple of mods this up a little bit on the ends and make the crocodile clip or alligator clip hold on to it better. Another couple of tapping points on there. One of those should give me 60 amp. My only concern is now that this is a 12 gauge cable, is only good for about 45 amps. So let's see. I've also turned the clamp meter up to the 600 amp range. No, we're getting serious now. Let's see if one of these will give me, one of these taps will give me what I need. Jump for big sparks now. How about that one? 53, not enough. Next one. 58, no. Last one. 63 amps. Let's start the video camera. Put that back in place. Here's hoping. So I probably want to get about 5 minutes at this, so if it's not going to work now, I'm going to cry. It's melting. It's melting. See if this will do any good. So I'm showing about 80. To 100 and something. 117. It's definitely going. You can hear it cracking, but that only shows me 106, so I've got it on my video, don't worry. See the smoke? It's coming off that near side connector. Yes. Die. That's a bit quick with the croc clip so I can disconnect that. Trying to blow the smoke away from it. A couple more seconds. Ah. 60 amps, that's what it took. That's good enough. And so it's conclusion time, I think. I'll show you that. See if I can get a close up. That's what happened to it. So what can we conclude from this, apart from the fact that I've got sod all better to do than melt connectors? Firstly is that these Tamiyas are good for about 40 amps. I ran it for about 10 minutes. Yes, it got all hot and sweaty, but apart from that, no major dramas. And at 60 amps, it shut the bed. There's no more to say about that, really. Oh, and as always, if you find that useful or interesting, feel free to buy me a kebab.